So on page 156, we are looking at polynomial functions. A polynomial function is one variable contains only one of the operations of multiplication and addition, with real number coefficients and whole number exponents. The degree of a function in one variable is the greatest exponent. For example, y cubed plus 2x squared minus x plus 4 is a degree of 3 polynomial function. The degree of the polynomial function indicates the shape of the function. Okay, so first off, all right, I don't know what the easiest way to do this is. Well, let's study the one that we know the best. Okay, y equals x squared. We've done a lot of work with y equals x squared. So, and actually I'm going to drop this down. So I'm going to make it y equals x squared minus 4. Okay? So, because we've done this, we know that our vertex is down here. Goes up this way and up this way. So, there's some new terminology that we have to understand that we didn't do before when we worked with this. Okay, the first things first. The degree of it. What is the degree of this polynomial function? 2. The degree comes from the exponent of the largest variable. Okay, the largest exponent for the variable. I don't know how to say that properly, but whatever. Okay, so I've got x squared. All right, if it's x cubed, it would be degree 3. X to the 4th, degree 4. X to the 5th, degree 5. All right, it's based on the equation. Okay. No, we've done all of this already in pre-calculus. So this is just going to be a review for those that are in pre-calc. Okay? This is called a quadratic function. Now the number of intercepts possible. So the number of x-intercepts for this equation, for a quadratic equation, is what?
1 less than the highest degree, or else the degree?
Not quite. You're thinking terms. I'm talking x-intercepts here. So you're also in the same ballpark, in the right ballpark. But how many x-intercepts can I have from an x squared equation? I can have a maximum of 2, right? I can have 1 if it touches it, and I can have 0 if it doesn't ever cross it, right? So 0, 1, or 2. So examples of that, all right? There's 1 x-intercept. There's 0 x-intercepts. Right? Because it doesn't touch it. Okay? The y-intercept, in this case, the y-intercept, there is only going to be one of them. Alright? This is new to you as well. Those of you that aren't in the other class. End behavior. So the end behavior works like this. You find out where it starts on the left, in which quadrant, and where it finishes on the right, in which quadrant. So this quadratic equation starts in quadrant 2, finishes in quadrant 1. So your end behavior is written like this: 2, 2, 1. That's the end behavior form. Okay? And this is for a quadratic equation. The domain for this x an element of all reals, right? Goes left forever, right forever. And in the range,
Y is greater than or equal to -4.
yeah. So in this one, because this is my low point right here, right? 0, -4, right? It would be y is greater than or equal to -4, where y is an element of all reals, right? Okay? But realistically, it'll be whatever that c value is. If you have a vertex of any sort. Okay? So far we're okay. This is not, the only thing new to you is we just are explaining how many intercepts we can have and the end behavior. That's new to you. Okay? Other than that, we've done all of this before. Before we did axis of symmetry, right? We did maximum and minimums. But we don't do that. All we're doing is we're focused on this end behavior and the degree of it. Okay, so that's that. All right, so now let's talk about. Thank you. Let's talk about a y equals x cubed graph. And again, I'm going to do it. I'm going to move this one to here. Go ahead, John.
Can you go back to the last page just for 1 second? What does it say right beside the
This.
coordinates? Yeah.
That was my sleeve making marks on that.
Oh, okay. Sorry.
All right. Okay. So y equals x cubed minus 8. All right. That graph looks like this. Okay. Sorry, I have to go back to this for one more. Not because my sleeve was under it. Okay.
I'm sorry to interrupt, but is there anyone from the Remembrance Day service that's in here?
Yeah.
Anyone that isn't, we need you down at the gym for sound check, if that's okay.
Yep. Sure. Go.
Okay. Thank you.
Okay. The other thing that we haven't done before. Sorry, and this is brand new to you. And Laura alluded to this earlier. The number of turns. What is the number of turns? How many turns does it make?
One less than number 3.
One less than your degree of it. Okay, Jenna, follow that? So this one only has one turn, right? The cubic function that looks like this, how many turns is it going to have? It's going to have 2. Okay, so that's always one less. All right, so looking at it, my y-intercept is what in this case? -8. How many x-intercepts can I have in this guy? X-intercepts. So what are my options? Is there ever a 0?
No.
Can I have 0 x-intercepts? No, you can't. Right? So the minimum I can have is 1.
2, 3.
I can have 2, or I can have a maximum of the degree, which is 3. Okay? So, an example of 2. That's 3. Rats.
Yeah, sure.
Oh, nice. Okay, so up, down, and then up. Well, that's supposed to touch right there. Yeah, you can see that touching. Okay? So there's an example of 2 of them, right? Okay? And then 3 is where I drew the other one incorrectly. Okay, so again, number of turns. Number of turns? 2. End behavior. 3 to 1. Okay, so the end behavior all right. Now, what we find out as we go through with this is the end behavior for all odd exponent degrees is going to be this, if they're positive. If the a value is positive right here. So if I have y equals a, and because we did this the other day, I'll do it like this, 2k plus 1. That's right, not quite close. X, 2k plus 1. This means that that's an odd digit, right? Because if I multiply anything by 2, it makes it even, and if I add 1, it makes it odd, right? So if it's an odd degree, your end behavior is going to be 3 to 1 if a is positive. If a is negative, that flips it. It's going to be 2 to 4 if a is less than 0. Okay, and that's for odd. All right? If that's a negative, I flip it. Okay? Now to go back to this guy, right here, right? If a is negative, what happens to my graph? If a was negative. How does it look? What changes? It reflects or flips over this axis and it's upside down, right? It opens down. Remember that? Okay, so it opens down. That means then the end behavior for an even one, I'll just do it like this, 2k. So if A is positive, then the end behavior is 2 to 1. If A is less than 0, the end behavior is 3 to 4. And that goes for every even degree polynomial. So that means if this guy is even right here on my largest value, okay, then it's that end behavior. All right, any questions so far? Okay, so in this section here, it's the 1, 2, 3, 4 of you that are in applied and not in pre-calc. You're the ones that need to ask the questions because they've all done this already. This was our first unit in pre-calculus. So if you need to slow down, if you need to look at something, you need to ask. You guys have to do it. Okay, Courtney? Okay, Jenna, you're okay? You too? Fine? Okay. All right, so look at 6.2 then.
Can you go back to the other slide, please?
Sure. All right, so now we continue on doing the exact same thing. It wants you basically to find all the characteristics. Now the beauty of this for the guys that are in pre-calculus is you have the cheat sheet in this one. So you can put all that information down, right? But now that you're looking at it, after you did this and you sweated through it in that first unit, now you're looking at it and saying, hey, this wasn't as hard as it seemed, right? Okay? But it sure was to begin with. All right, look at the tips. There's 2 of them on page 158. Okay, the standard form of a linear function is y equals ax plus b. So that's in slope-intercept form, right? Standard form for a quadratic function is y equals ax squared plus bx plus c. And the standard for a cubic is ax cubed plus bx squared plus cx plus d. So a, b, c, and d, and that are all just numbers, coefficients, right? And those are represent the polynomial function. Now the difference between the pre-calc and the applied is you're not going to go any higher than a 4th degree likely. You'll just stick to the 1, 2, 3s, and 4s. Second tip, in your descriptions of characteristics of a function, include the following. So if you're sketching it, you need to include all of the following. Your x-intercepts, the y-intercept, the end behavior, the domain, the range, and the number of possible terms. So, looking at it, number of x-intercepts, that varies depending on the degree of it. Okay, it can be an even number can have 0, 1, 2, 3, or to the amount of the degree. Okay, so does that make everybody understands what I'm saying? So if it's a degree of 8, you can have up to 8 intercepts, or you could have 0 intercepts. But an odd function, you can never have 0 intercepts. You have to have a minimum of 1. It has to cross the axis. Okay? Y-intercept will be 1. The number of possible turns is 1 less than the degree of it. All right? Look at the example 2 on page 159. Match the graph to the correct polynomial function. All right. What's the difference between the two equations?
Of the equations, negative x and positive x.
Negative and positive. So which one represents the negative x squared?
A.
A. And B is obviously the positive, right? Because of the A value. If A is greater than 0, it opens up. If A is less than 0, it opens down. Agreed?
Mm-hmm.
All right. And how many turning points on it?
1.
What's the end behavior in A? Shayla?
Excuse the interruption. Any students who are participating in today's ceremony in the way of reading or singing or playing Gatorade, if you could possibly come to the gym right away, we'll do a quick sound check. Again, thank you.
Okay, on A, which quadrant does it start? Looking for the left side of the graph, which quadrant does it start? Okay, so I'm looking at my graph right now, Sheila. Okay, You know all the quadrants are numbered, right? 1, 2, 3, and 4, right? Yeah. Okay, so here, and which one does it end in? That's right, good for you. Okay, so number of the quadrants is probably the issue, right? Okay, what about B? Chantel, what's the end behavior in B?
2.
Okay? And that's it. Like I said, the end behavior is the only thing that you have that's new to you. Okay, everything else we've done up to this point. That's it. I don't want to rush through anymore.
Are we gonna have to start turning these?
I do this every day.